Hello everyone, welcome all to Physics with Astronautics. So in this video, we will discuss about some CPET 2023 physics solution. So let's begin. And here is our first question of this session, that is del cross E is equal to minus del P by del T. Equation is related to, and here the options are Gauss law, Bauer-Savar's law, Ampere's law, and Faraday's law of electromagnetic induction. And here the final answer is Faraday's law of electromagnetic induction. Then if E k dot r minus pt and p k dot r minus pt satisfies Maxwell equations, then E by B each equal to, and here the options are 1 by c, 1 by c square, and root c. And again here it has been given that here c is the velocity of electromagnetic wave, and here the answer will be C. I mean option B, and the correct answer is C. Then for normal incidence, reflection coefficient of the surface is given by, and here the options you can see, and here it has been mentioned that N1 and N2 are refractive indices of medium 1 and 2 respectively, and we know that the reflection coefficient is equal to the square of n1 minus n2 by n1 plus n2. So here option A is the right answer. Then if a beam of polarized light has 1 by 4th of its initial intensities after passing through an analyzer, then the angle between the axis of the analyzer and its initial amplitude of the beam is. And here the options are 30 degree, 45 degree, 60 degree, and 90 degree. So let's come to the solution. Let the initial intensities of the polarized light be I naught, and the intensities become I naught by 4 after passing through the analyzer according to the question. And we know that I naught cos square theta is the final intensity, because here it has been given that this is the polarized light. So by putting the value here, we can find that cos square theta is equal to 1 by 4, or I naught cos square theta equal to I naught by 4, so that cos square theta equal to 1 by 4, and from here cos theta will be 1 by 2, and theta will be cos inverse 1 by 2, that is pi by 3, and this is 60 degree. So here the final answer is 60 degree. Then the thickness of half wave plate for wavelength 5000 Armstrong each. Here mu e is given as 1.55 and mu naught is given as 1.54. And here the options. We know that the thickness T is equal to lambda by 2 mu e minus mu naught for half wave plate. And here by putting the value, we can find that the final answer will be 2.5 into 10 to the power minus 3 centimeter. So option D, which is 2.5 into 10 to the power minus 3 centimeter, is the correct answer. Then if two thin convex lenses having focal length 5 centimeter and 4 centimeter are coaxial and separated by a distance of 4 centimeter, then the equivalent focal length each. And we know the formula for it, that is 1 by f equivalent is equal to 1 by f1 plus 1 by f2 minus t f1 f2, where f1 is the focal length of the first convex lens, f2 is the focal length of second convex lens, and d is the distance separated. So by putting all this value here, we can find that the f equivalent will be equal to 4 centimeter. So here the final answer is 4 centimeter. Then condition for bright and dark fringes for Newton's rings, its transmitted and reflected light are reversed because the options are transmitted ray has a phase reversal of pi by 2, reflected rays has phase reversal of pi by 2, transmitted ray has phase reversal of pi, and option D says reflected ray has phase reversal of pi and transmitted ray uh, has a phase reversal of, I think this is 0 degree. So the final answer will be option D. Then radius of first half period zone of a zone plate behaving like a convex lens of focal length 50 cm with lambda is equal to 5000 Armstrong each. And here the focal length is given as 50 cm. The lambda value is 5000 Armstrong, and we know the radius is equal to root over of n d lambda. So by putting the value here, and it has been asking that the radius of the first half period zone. So here n will be 1. So the radius of first half period zone will be d equal to 50 centimeter, that is 50 into 10 to the power minus 2 meter, and lambda is equal to 5000 Armstrong, that is 5000 into 10 to the power minus 10 meter. And by solving it, we can get the final result as 5 into 10 to the power minus 2 centimeter. So here the option C is the correct answer. Then the product of troop velocity and phase velocity of relativistic particle is, and we all know that the product of troop velocity and phase velocity, that is Vg into Vp, is equal to c square. Then if a particular mass 3m is at rest and decays into two particles of mass m and 2m with non-zero velocities, then the ratio of the de Broglie wavelength of the particles of mass m and 2m each. Options are 1 by 2, 1, 2 and 1 by 4. So let's see what will be its solution. And here we can see that this is a particle with the mass 3m and it decays into two particles, that is of mass m and mass 2m. So by applying the conservation of linear momentum, we can find it as m, the initial mass into initial velocity will be equal to the sum of the final mass and final velocity, that is 3m into 0, because the particle is at rest initially, and is equal to m into v1 plus 2m into v2. And from here we can get that v1 plus 2v2 will be equal to 0, and v1 is equal to minus 2v2, or v1 by v2 is equal to minus 2. So we know that de Broglie wavelength lambda is equal to h by mv. So here it has been asking that what will be the ratio of the de Broglie wavelength of the particle of mass m and 2m. So the ratio will be lambda 1 by lambda 2, that is for mass m1 and mass m2 will be equal to h by mv1 by h by 2m v1, sorry v2, because here the first particle is with mass m and the second particle is with mass 2m, and this will be 2m v2 by m v1. This m and m cancel each other, and this 2v2 by v1 will be equal to, from the above equation we can get that v1 is equal to 2v2. So here 2v2, in place of 2v2 we can put v1, and the answer will be 1. So here the final answer is 1. I hope you all enjoy the session. So for more videos, please do like, share and subscribe. Thank you.